Hello everyone, and welcome to the second video in a series where we build a custom environment for training and testing of a deep reinforcement learning algorithm as applied to portfolio optimization. As I said, this is the second video, so if you haven't seen the first video, I highly recommend that you go back and review it because this is a continuation of it, and so there's several things here that probably won't make much sense if you haven't seen the first video. And in that previous video, we did the building and testing of a CPU instance. Here, we're going to start off by doing the GPU instance. It's going to be very, very quick. Effectively, it's identical to what we did before, except in this one, and I'll just run all these cells while we're talking. It's going to start off with a build and push command to that same script. The only thing, if we go back here, the build and push script didn't have an argument. Now we simply have an argument for GPU. So it's going to go in again, just as I mentioned, grab now a new PyTorch. The only difference is the instance that it starts with is a GPU instance, not a CPU instance, as the base. And then when it goes through and applies all the different Python packages, especially the PyTorch one in particular, it is GPU specific. And it's going to push that image back up. Because I did it recently, you can see that actually there was nothing changed, so it didn't take very long here at all. And then once it's pushed, goes in and finds it. Again, very, very similar. The only difference here now, it's a GPU. And we go and build the estimator. Again, identical to what we had before. The big difference is that the instance type is now this G4DN, which I'll show you in a second. It actually is a GPU instance, not a CPU instance. And we're just going to train it for, again, 200 epochs, or we'll call them tennis matches. Not enough to do a real fit, but enough to make sure that all of the system is working properly. And so while that's training, I'm actually going to just jump over to and kind of get ahead on the sensitivity one, the pricing and the instance types. So in here we can see I'm actually using US 1, which is like the North Virginia. And so if we go into model training, for instance, there's all these different types of instance types, and these are the things that I'm including in that one field. And you can see the price per hour varies considerably, right? So some of these are just, cents per hour. Some of the bigger GPU instances get up to, $43 per hour. So a huge difference in price between the different instance types. And then if we can go over to this one where you can see for each instance type, the number of CPUs, GPUs, how much memory, and the network performance. And so you notice the GPU column here is blank for pretty much all of them until you start to get down in here where we have the P series, and then now we have the G4DN series. So these are have different GPUs attached, different GPU types. You can see different generations of GPUs themselves, and then also different memory and network capability. So as we're building this, we'll see it's already started to launch that job. I'm actually just going to hit pause here and wait for that to finish up. Okay, so that finished. And actually, while I was just looking at the output here, which again, very similar to the CPU one, except of course it's grabbing a GPU instance instead of the CPU instance. And it just sets all the environment variables. Here we can see this line. This command, the train here, literally came from the fact that when we built that image, we set the environment variable, right, to train.py, and so that's where it knows. And then the epochs here, that's literally the hyperparameter that we passed in. So when we start doing our tuning, we'll just pass in different arguments. And if we go back into the container, as we mentioned previously, or showed previously, in train.py at the bottom, you can see these are all the arguments with default values. So we only pass in one argument at this time. The default was 2000. We're passing in just 200, so we're overriding the default. And all of these other arguments will, of course, get the default values. But when we do the hyperparameter tuning, we can tune these. So that was the GPU. Again, 147 seconds. Very similar to the one before. We pull back the image. You can see very little training happened here in the first 200. As compared to what we expect to see, where we get all the way up to 0.5. But that's just, again, because we are not training for very many episodes. We're just trying to get an idea for what the, making sure that all the system works. So with that, just 4 minutes, we'll jump over into the, the sensitivity one back here. Okay, let me run everything while we're talking. So in this one, what we're going to be doing is I went into that website which showed previously. I just copied in all of the prices that were there. Obviously, this is something you probably want to go back and have a look at, update for your particular region if you're doing a different region. And as time goes on, of course, it'll have new instances here as well. So it just builds this up into a pandas data frame where we have all the prices, the type, and then the job name and time is, of course, going to get populated as we go down here. And we submit all the jobs. So here it's going in, and it's just got a loop. It's going through all of those where it's submitting, it's creating an instance of that estimator. And then it's just saying the instance type, which again comes from here, right? Instance type is just going to be CPU or GPU. I'm sorry, the instance type here is the index, which that didn't make much sense. So this is literally the instance type, the name here. And then it's the image name. And the image name really has the, whether it's a GPU or CPU. And then the number of epochs, I think we set it for 3,000 in this particular one, so we're going to spin up a much bigger job here now. And the big thing is when we say fit, we pass in this weight equals false. That way one's not going to sit here, it's just going to go through, submit all, what means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different jobs. And then when it comes back here, we're going to do into a little loop where it's just constantly going through and polling, gets the job names. Now we have all the job names recorded. You can attach to the particular job name and then get the info so we can get the status to say whether it's completed or failed. If it's completed, it just records the billable seconds. If not, it just comes in here and sleeps and waits for a minute. So it's going to go do that. And while that is looking, I thought I'd actually take the chance to jump back into this interface. And you can see here's the instance, but if you go down to training jobs, we can see now that all these jobs are now spun up. So they're all in progress. And if we go over here, we can actually see more training jobs. See, I've done a bunch. We did the previous GPU and the CPU one, for instance. So if we scroll back, right, that's the GPU instance that we tried. I actually did a second one. I kind of messed up one of the videos here. I had to do it the second time. And that's the CPU that we did earlier. So they've been completed. These are all in progress. If, for instance, you wanted to go in, it's kind of nice here. You can click on one of these. It gives you a bit of history. And what is really nice is you can view the logs. Right, so this is CloudWatch now going in and looking at that particular instance, getting all the information back from it. It's a good way when you start having to debug in that, you can kind of follow this and go in and see exactly what your different training jobs are and what they're doing. So let's go back into the sensitivity. And yeah, so it's just going through now. It's going to have to wait. It's going to take a couple minutes. So with that, I'm going to pause it and come back when these training jobs are finished. Okay, so they're not all finished yet, but I thought I'd come back. You can see that as it goes through, it just kind of prints out which of them completed. But I also thought I'd take this opportunity to just jump over here now back into that training job so you could see how most of them have finished. There's just one left. What's really interesting is you can kind of go in here, and this is what we're going to use in the next section. So I thought I'd just take the opportunity now. And if you go down, you can kind of see some of the metrics on the memory and the CPU usage and that sort of thing. But what I am looking for is the logs. Here we go, view logs. Which jumps you over into CloudWatch. And now that it's started, you can see you have this log stream that automatically gets created. And this is very similar to the data you saw coming out previously, but it's obviously in a much cleaner form. And it just shows the output. And it comes down through. And then we finally have down here this training objective. So this log trail that's here, that's in CloudWatch, this is something that we're going to parse to pull out the objective function. So we're going to have a regular expression that's going to pull out this particular thing. But you can see here, for every single one of the training jobs, this gets generated, it gets captured here. It stays, so you can go back and check later to see if anything happened. And you get a little bit more detail on some of them if they have extra detail. But again, it's just a nice way to kind of see exactly what's happening on each particular job. And if we go up, we can see here's the job name. That's the thing that we are recording. So this job name that has a particular log that gets recorded. So anyways, I just thought I'd go and take that time to check this. And let's just go back into training jobs. So we still have one more. It's kind of interesting that it's taking them so long. And actually, in retrospect, if I was going to redo this sensitivity, I had 3,000 seconds here, and that's probably too many because it means that some of the jobs are going to finish and some are not, which your timing may be slightly off now, of course, because some jobs, there's a bit of uncertainty in when the jobs are. So I'm just going to pull this back to 1,000. So the next time you go through, the jobs will finish a little bit quicker. Because if you remember, if we go back to this one, what we're expecting is it's going to finish in around 1,700 iterations. However, that varies. If you just run this over and over again, it won't always be 1,700. So I'm going to pull it back to 1,000. That way, there's enough runs so it's representative, but yet you're not going to get extra noise put in the sensitivity due to the fact that some of the jobs finished early and some went a little bit longer. So with that, I'm just going to hit pause one more time onto that very last job, which seems to be going a little bit slow, is finished. And when we come back, we'll see what the results look like. And actually, while that last job is running, I just took just to jump in, you notice that it's a GPU job. It's taking a long time. So I just kind of wanted to go in here in CloudWatch and check it, see what's happening. And here's kind of something interesting, right? The CPU utilization is over 100%, so it's effectively using more than one CPU full time, whereas the GPU utilization is very low. So this again shows the fact that this particular job is probably not a great job for GPUs. It's probably, without even looking at the results, I'm going to guess that GPUs on this job, it's not the best. This seems to be more of a CPU intensive. And then the memory, again, very low. Disk is almost nothing. So very little. It looks to be mostly a CPU job. So I'm expecting that probably the instance type that is best suited for this is a CPU job. And if we can go in and view the logs themselves here, for this is the very last one that's left to go. We can jump in. And this is just a good idea to give you an idea. See, and it's finally finished. It just finished for us there then. And it got there in a little over 1,700 steps. So if we go back to all the training jobs, so there we go. They're all finished. Now we have all of these done. Now it's sleeping, of course. So it's going to take the rest of that full minute before it realizes that the job is actually finished. So I'm just going to pause for just a few seconds. Oh, I don't even have to hit pause there. I finally finished when it came through. So now we got all of our jobs back, the time and the cost. And remember that the cost is in seconds or in cents, and the time, of course, in seconds. And then we also made an efficiency, which is just simply the cost times the cost times time. And there we go. So here's our plot. So this kind of shows us, how much each of the jobs, what was the best performing job. And so you can see here that this job, which is the one we're waiting for, right? It was the real outlier, was actually one of the P2s. So that was one of the GPU instances. And you can see it was the slowest one. And because it's slow, of course, that drives up the cost. So there's a natural correlation between the two. And we can see it also kind of prints out which one was the cheapest and which one was the fastest. So the M5 large was the cheapest instance, and it's saying it's the most cost effective. But the fastest one, which is just barely, you can see was up here, which was the G4DM, which actually was a GPU. So it's quite interesting, right? The different types of GPU. This GPU was the fastest, and this GPU was the slowest. So, if you go back and look at those instance types, you might be able to get a feel for why it was that way. But in general, going forward then, this would be the instance type that I will use when I go into my sensitivity study, which I'll show next. And I'm just going to stop the video there so we can start up with a blank slate. Okay, thanks, and I'll see you in the next video.